Hi, everyone, and welcome to today's webinar, How INX Connects Predictive Maintenance to Action. I'm Leanne Baker, Senior Integrations Product Manager at AssetWatch, and I'll be your host as well as your presenter today. Before we get started, a few housekeeping notes. First, this session is recorded and will be sent to you post-broadcast. Second, we'll be answering questions live at the end of the session. Please drop your questions in the comments box throughout the presentation. We'll answer as many as we can during the live, and we'll also have experts from both MaintainX and AssetWatch in the chat to get your questions answered as well. We're excited to have you here as we dive into how INX has built a connected, results-driven maintenance strategy, bringing together insights from AssetWatch and MaintainX to drive real-world impact on the plant floor. If you've ever felt stuck between knowing something's wrong and getting something done about it, this session is for you. You'll hear directly from Chris Rogers, VP of Operational Excellence at INX International, Chris Hudson, Director of Lifecycle and Manufacturing Solutions at MaintainX, and me. Each of us will share how INX is bridging the gap between data and action and aligning people, tools, and processes across their operations. I'll hand it over to Chris Rogers first to introduce himself.
Hi, I am Chris Rogers. I am the Vice President of Operational Excellence here at INX International Inc. Company, where I'm responsible for our Industry 4.0 initiatives. That includes the implementation of AI, SCADA, and connected worker technologies across our global operations. I've been with INX for more than 30 years, including R&D, technical service, and continuous improvement work, where I built the company's TPM structure and developed our PMT, or project management tool. I've also expanded operations for our SCADA systems across our operations. And I hold a BS in Polymer Engineering and a Master's in Management and Leadership, as well as a Lean Six Sigma Black Belt. My vision for INX as we move forward with Industry 4.0 is to foster a culture of continuous improvement that drives efficiency, safety, and customer value.
Chris Hudson.
Thank you. Hi, Chris Hudson. Prior to joining MaintainX, I spent 3 decades in the automated material handling and packaging systems industry. I was able to leverage technology in my roles, starting out as a manufacturing engineer, manufacturing operations, maintenance management, and leadership in multi-site facilities. I was also able to spend half of my career in aftermarket lifecycle service and support, helping customers with discovery and solutioning, being able to visit over 100 sites. In my career, I was able to really see firsthand some of the benchmarking and solutions in automated manufacturing, food and beverage, and warehouse and distribution. I guess what's unique about me is prior to MaintainX, I was a customer of theirs for 4 years, where similar to today's subject, I was able to leverage the enterprise asset management tool to connect our previously disparate ecosystems and integrate to a connected factory operating system. MaintainX and I have been delighted to participate with INX and AssetWatch in this partnership from project inception. And we're excited to be able to participate today in highlighting this project and some of the outcomes. So thank you for the opportunity, Leanne.
Thanks. My name is Leanne Baker, and I serve as the Senior Product Manager for Integrations and Marketplace at AssetWatch. In my role, I oversee how AssetWatch connects with external platforms from CMMS and EAM systems so that our customers can seamlessly move from asset alerts to action without disruption or loss of data. Much of my work centers on building these integrations to improve reliability outcomes, enable automation, and create a 10x experience for our customers. With that, let me go over the agenda for today's webinar. We'll be setting the stage and talking a little bit about INX International. INX will then give us a wonderful spotlight of their journey to Industry 4.0. We'll then have a deep dive on how tools are shaping reliability. We'll have a panel discussion with lessons learned and how that scales across sites. And lastly, we'll close with some key takeaways and a live Q&A. With that, I'll pass it to Chris to talk a little bit about INX International.
Thanks, Leanne. So yes, INX International, we are a global manufacturer of high-performance printing inks and coatings, just like it says. Simplest way, if you want to see any of our products, is go to any store. If there is color on the packaging, we make ink for that, especially aluminum cans. We are the largest in the world for the coatings and ink, or for the ink on aluminum cans. But pretty much any type of printing application that is commercialized right now, we do make printing ink for that. Along with our parent company, we are the third largest in the world. This map just gives you a quick overview of where INX International and our parent company, Cicada Inks, where our manufacturing sites and distribution sites are located around the world. So we decided some time ago that we were a little bit behind on the technology scope and decided to start an Industry 4.0 push, starting in the US and then expanding into international operations as well. So one of the things that we saw were that there were issues, so we needed to make sure that we had a very good roadmap. This roadmap actually shows the most recent implementations that we have done with MaintainX moving into all of our sites. Prior to MaintainX, we had implemented SCADA systems at most facilities and a web-based MES type system in Odin, as well as implementing AssetWatch at most of our sites. So you can see the roadmap, which is very critical to have a roadmap and a plan for where you're going to make sure that you're on track to what you want. So we started with a single plant, and we did that with all of our implementations. That plant happened to be in Charlotte, North Carolina, where we started as a proof of concept. We moved forward with that to making sure that we could create standard operating procedures, asset lists, parts lists that could be used across multiple plants. And then we started expanding. Of course, you can see on the bottom of this, the Learning Center, because training is absolutely critical. As we move forward, we did start expanding this into our other sites. So once it's expanded and utilized in other sites, we started talking about integrations. So there are three main companies that we integrated. You're talking to two of our partners today, which is AssetWatch and MaintainX. And then also we're integrating a company called Odin. Since AssetWatch, as you'll see in a little bit, can tell us a lot about the state of the equipment, and MaintainX is perfect for making sure that we're doing our preventative maintenance, that we have all of our work orders and all organized, that we have our parts list organized. Odin is able to give us real-time uptime and downtime, or running hours for those machines. And then, of course, as we move forward from that integration, we will be looking for more operational KPIs to prove out the effectiveness of all of this.
Chris, I appreciate you showcasing the roadmap, and I think, as part of the project implementation team, I also want to call out that, early in the project charter, that INX define not only current and future state, but a clear problem statement, objectives, and timelines. In addition to the clear project scoping, after implementing that proof of concept site in just a few short months, I think it was really a milestone in the project during the phase plan that INX also hosted a collaborative Kaizen event with INX leadership, partners, and project team to really talk and showcase the lessons learned to date, the standard work, and next steps. Can you talk a little bit about how INX does that during their project methodology? And then I guess, Leanne could highlight some of the system architecture in play here.
Sure. So from basically what you said, it is part of INK's culture to scope every project that we do. to make sure that we have all of the key players and all of the major interested parties involved from the beginning. I mentioned earlier the PMT when I was introducing myself. The PMT is our project management tool. It is Microsoft based. We built it on the Power Apps platform. It is designed for exactly what you're talking about, for making sure that you're properly scoping your project, that you are completing a project charter step by step, and also that you're making sure you're doing management of change. Because when you change these things, you need to be scoping that, deciding who's going to be involved, who it's going to affect, and who needs to be trained once things have changed.
It was such a great overview. Thank you so much for that, Chris. With that, let's dig a little deeper into how the integration works between AssetWatch, MaintainX, and INX. Here's how the integration creates a seamless loop for INX, from early detection straight to resolution. It starts in AssetWatch, where our platform continuously monitors the assets for vibration, temperature, and performance anomalies. When we detect an anomaly, the integration with MaintainX automatically triggers a work order. So there's no manual entry, no delays. That work order is then routed straight to a technician who now has all the context that they need. They have the diagnostics, they have the procedures, they have the recommendations from what our condition monitoring experts provide to them, and what to check and what to replace. Once the repair is made, the data flows straight back into AssetWatch, closing the loop so that the system has a resolution in place, and our condition monitoring engineers can close that alert. This enables us to not only detect issues faster, but we also continuously improve the accuracy of our alerts and our recommendations so that both MaintainX and INX benefits from this. Chris Hudson, maybe you'd like to talk a little bit about the top challenges for INX.
Yeah, I think, in the real world, no project is without headwinds. And we're excited to hear Chris describe some of the top challenges that INX discovered during this phased approach. I want to suggest, Chris, in your user documentation and requirements, retrospectively, can you elaborate on the importance of the change management strategy that you indicated, knowing that the majority of your workforce is mobile and they do require real-time ingestible data that's easily accessed from connected equipment to drive expected outcomes and the reliability and root cause corrective actions that you were part of your objectives?
Sure, Chris, I can talk to that. It's important to know that we're kind of a mature company. We have equipment that ranges in age from more than 50 or 60 years old to equipment that was installed in the last month or two. So you can imagine the difference in what you get from a very old piece of equipment with no integrations to a new piece of equipment that may be controlled by a PLC with an HMI directly on it. So some of the things that we fought against were machine reliability. Some of the older machines, the reliability is good as long as you know when to do preventative maintenance. A lot of the newer machines, the reliability seems to be very good, but you need to be able to have that real-time data that tells you how the machine is running, and also is anything not performing in the way that it should be. Our current CMMS, when we started this, was just completely outdated. It was very difficult for people to use. You mentioned mobile. There was no mobile access. So maintenance technicians, supervisors, managers, anyone who wanted to put information in for a work order request or to repairs, any type of request, had to go back to an office, go back to a computer, sit at their desk, open up the platform and type things in. That takes a lot of time. The other problem we ran into before AssetWatch and MaintainX, too much reactivity. We were fighting fires every day. If a machine had a problem, you didn't know it until after it became a major problem. You didn't know that it was starting up. You didn't have the ability to head it off before it became a major breakdown. And then, of course, time-consuming failure investigations we list on here. I really, if I pull the cover back a little bit, a lot of the investigations simply didn't happen because of the amount of time required and the difficulty of completing those in the current platform at that time. So we really weren't doing enough root cause investigation of what caused the problem. They were simply repairing it and moving on to the next fire that they had to fight.
Do you think that's exacerbated by, a cold trail and the inability to have more real-time data? It was more lagging indicators?
All of the data was lagging. The biggest exacerbation to that, I think, and the biggest frustration for our maintenance staff and for our engineering is that without that history being kept in there, you tend to repair the same things over and over again when it could be an engineering fix to eliminate the cause so that you don't have to ever repair it again.
Hearing your insights on some of your top challenges is very helpful, and I'm sure our audience appreciates that. With that, I'd love to turn it to an audience poll and see what their biggest challenges are today. If that's unplanned equipment failures, if it's outdated CMMS or asset histories, if it's reactive firefighting, investigating failures, or anything else that we might not have listed here, please feel free to drop in the chat. We'd love to see what it is. I'll give it a few minutes, but right off the rip, looks like we have a lot of the reactive firefighting that you mentioned, Chris. That was also one of INK's challenges. A few others coming in here for the unplanned equipment failures. A few more trickle in. It looks like that reactive firefighting might take it as our top one here, coming in at right around the 40% range.
It is interesting to see these kind of resonate with our audience and that they're all top of mind. I think we'll be able to highlight towards the end of the webinar some of the outcomes that were experienced from this fully integrated partnered platform.
That was great to see. With that, I want to pass it back to Chris and hear a little bit more about the reliability initiative.
Sure. So part of our Industry 4.0 push is to make sure that we make our machines more reliable, right? So it should be a core piece of anyone that's trying to move toward more automation is to improve reliability. So we decided we had to upgrade our CMMS system and we had to look for ways to improve the reliability of our equipment. So some of the goals that we look for are listed here on this slide. We wanted to standardize maintenance across our sites. We have multiple sites. They do not all do things exactly the same way. And we wanted to, wherever possible, make sure that was standardized. We need to eliminate those failures so that we're not fighting fires. We can plan our maintenance in advance. Spare parts inventory, since we do have common equipment, not only across some of our US sites, but globally, some common equipment, being able to integrate spare parts across all of our sites so that instead of always trying to get something from vendors, which many of the people on this call probably can relate, sometimes you have a vendor that has the parts in stock and can get it to you in days or weeks. And sometimes you have vendors that can't get you the spare parts for months. So being able to stock that, have it for common equipment is a huge plus. Driving our global reliability culture, of course. And then, of course, being able to integrate the systems into each other puts me further forward in my Industry 4.0 push. And having the integrated information from the three platforms talking to each other in a partnership really helps me move forward with integrating the frontline workers and our maintenance staff into everything else that's happening. So we did, as we entered into this, we did look to reduce mean time to repair. We set a goal of 50% at the time. And then, of course, increasing mean time between failures. As I said before, though, in our previous system, not everything was updated when it was supposed to be or as it was supposed to be. So we're actually using the new system to benchmark both of these.
With that, let's go a little deeper and see how it works. So AssetWatch, we detect and learn. It's AI-powered condition monitoring, vibration, temperature. We have anomaly detection. It catches gradual trends and rapid spikes. We have actionable alerts and diagnostics, so it's not just data, it's actually answers. And we have issues corrected off hours and by changing PM schedules. With that of how it kind of works with AssetWatch, Chris, I'd love to hear from you of how AssetWatch works for INX.
So one of the game changers for us with putting AssetWatch on our equipment has been being able to see when there is a problem before it becomes a major breakdown, or before what I talk about as firefighting, which is kind of a term that we use internally, but really that is any kind of unplanned breakdown or unplanned losses of equipment that you run into, where you're going to immediately call maintenance staff and say, you've got to fix this now. It's stopping production. So by putting AssetWatch sensors on all of our equipment, it's probably important to say here that we separate our equipment out into A, B, and C categories. A being your critical, must run, have to run, can't be down type of equipment, and moving out towards C, which is things where you may have multiple of. And we did decide to put these on all of that equipment, all of the ABC, or all of the A equipment, and then most of our, what I would call auxiliary equipment, or your service equipment within the facilities, like things like air movers, air handlers, air compressors, nitrogen generation if you have that. In our case, we have dust collection systems and other types of ventilation required. So all of those systems are things that you don't see.
I think it would be great now to see what this looks like in action, how AssetWatch helped get you some measurable savings at one of your sites. This example comes from your Charlotte, North Carolina site, where AssetWatch detected an early stage bearing failure on the 3-roll mill. Perhaps you can elaborate a little bit on this and how it worked out for your team.
Sure, absolutely. So the 3-roll mill is a core piece of equipment for the Charlotte site. This would be an A-ranked machine. Without the 3-roll mills, our Charlotte facility does not get their product out the door. There's not a lot of backup equipment. So one of the things that happens, the 3-roll mill is not a high-speed machine, but you can't really tell a lot from the image there. They are very large motors. They turn slowly, but with a lot of force and a lot of energy. So as things wear out and start to vibrate, you don't really notice it if you're just standing beside the machine. AssetWatch was able to notify our maintenance staff ahead of time, that there was a vibration, and you can actually see the trend chart there. And once that vibration hit, we were able to stop the equipment before catastrophic failure happened. We still had to resurface the grinding rolls on the machine and replace the bearings. But if you continue after the first failure, you destroy the rolls, and instead of resurfacing them at one price, you end up replacing them at 3 to 4 times the price. So we were able to prevent the additional damage and restore them by shutting the machine down and scheduling it to be down instead of having that catastrophic failure.
I will say it's always great to see when our condition monitoring engineers make such an impact. We're one of the few that don't just use AI to detect anomalies, but our condition monitoring engineers are a part of your team, almost they're an extension of that. To see when their recommendation helps you avoid some catastrophic failure, it's so nice to see that work in action. I think we do one more case study. This one is for your main plant air compressor. It was with a cooling fan and a thermal valve fault. Perhaps you can elaborate a little bit on this case study as well.
This one is one of my favorite case studies of our early successes with AssetWatch in the Charlotte facility. This was not something that would have been prevented by a preventative maintenance, because the preventative maintenance was done, but an item was missed. And because of that, the temperature in the enclosure began to rise very fast. And anyone who deals with rotary screw air compressors knows that there is a limit to where the temperature can handle before you start having major issues with that air compressor and with its ability to do its job. The sensor had only been on there for actually a short time, just a couple of months, when it notified our maintenance staff in that facility that the temperature was up 70 degrees above the baseline, which is a danger zone. It's a very scary time. Maintenance immediately went out and checked it. They were able to do some cleaning, replace filters, and the temperature dropped, as you can see in the chart, right back down into the range that it should have been in. So this was a very big savings for us, because if the air compressor goes out, you're down. A lot of equipment is down, a lot of time is lost, a lot of cost to be able to get that machine back up and running quickly so that the plant can get back up and running. And Leanne, it's important to say here, it's not just the AI that's sending these insights to our maintenance staff. It is, as you mentioned, your condition monitoring engineer who's reviewing that, sending it to them. And our staff at most plants is meeting on a regular basis with their representatives at AssetWatch to review the data that's come out, so that we know that our people understand completely what the recommendation is.
It is great to see when detection goes all the way from early stage alert straight through a resolution, and one that worked out so well for your team. With that, I want to pass the ball over to Chris Hudson to talk a little bit about the MaintainX portion of this, of the total productive maintenance.
Yeah, thank you. You know, in today's smart factories, optimizing the Class A equipment around both production and support equipment starts by, applying the 3 C's, connecting, collecting, and correcting. And so by interpreting early the anomalies and these digital signatures, you're able to really run the root cause, things that could be catastrophic, as Chris described, and to be more predictive around when to take equipment down and how to optimize their performance. Additionally, another facet of INK's program has to do with using and leveraging subject matter experts in building out a supplemented total productive maintenance system with autonomous maintenance. And these insights can enable accurate and impactful requests at the point of work with both fixed workstations and mobile devices using smart QR codes. So what we're showing here is, Chris, if you want to elaborate on how you go from real-time scan, repair, and visualization of some of the subject matter expert generated data, talk a little bit about how your frontline teams are having an easier time in this workflow of scan, collect, repair using a pre-populated red tag.
Thanks, Chris. So you mentioned autonomous maintenance. So most of our operators are trained and certified internally for autonomous maintenance, meaning that they do a lot of the basic maintenance on their machines, sometimes lubrication, most of the time all of the inspections, cleaning on equipment. So when they run into a problem, they know that it is definitely something wrong. Previously, that was all paper. It was a red tag, a physical tag the operators filled out by hand, turned into their supervisor, who then entered it into the old CMMS system, and then carried a copy of it over to the maintenance staff to make sure that they knew it was there, because they weren't getting notifications automatically. Now, if an operator is doing an inspection or a lubrication or anything else, and they need maintenance assistance on that equipment, they can literally click on their computer screen, which because of our integration, most operators have access to either a thin client or a PC on the production floor. Or in places where they don't, they have mobile devices, such as provided phones or tablets. They're able to scan the QR code. The QR codes, as he said, are smart. It's because I found it interesting that if I scan the QR code with a device that does not have a logged in version of MaintainX on it, it simply opens up and lets me enter a red tag immediately. And if I am inside MaintainX when I scan the QR code, it brings up the information for that machine. So it knows where you are, it knows what machine it is based on the QR code. And once it brings up the red tag, as you can see, it is a very easy mobile interface, very simple to do. It is a request form, so it goes directly to the maintenance staff. The operator can upload a photograph if they need to. They can complete everything they need on the mobile device, or they can add information on a desktop if that's easier, or if it's closer by, if it's in their work area.
Yeah, I know, we've seen literally hundreds of red tags that are generated by your operators and subject matter experts. And because automation requires human interoperability, this process and quick workflow makes it an easy tool at the point of work for your frontline teams to really generate not only opportunities for maintenance and reliability improvement, but they can put in other requests around safety, compliance, and improvements around your total process, kind of completing the closed loop plan, do, check, act wheel, because they get notification back that their idea or their red tag was submitted, when a work order is then approved, and the outcome. And of course, adding this additional layer of data onto your automated machine learning modules and models within AssetWatch, again, just gives you the ability to connect with those subject matter experts. I guess if we move towards some of the outcomes that are captured, could you talk a little bit about, in that empowered process, how you are sharing this workflow and visualizing the outcomes that are generated through your TPM process?
Sure. So we've been on a TPM journey for a very long time. So we're very mature in most of our tracking of results. But like I said before, we've had issues with MTTR and MTBF before, and even cost, because the data was not real time. The data relied on maintenance staff who had to go back to an office to be able to put the information in. And a lot of times it just either didn't get entered or it got shortchanged. It wasn't what it needed to be. Now, because it is much more real time, we can kind of enforce compliance, might be a good way to put it, to make sure that we actually get the correct information. So we are making sure that we're able to audit everything. We're making sure that everyone who uses the platform has the correct safety information, has the correct machine information to do the job quickly, efficiently, and to make sure that they're documenting what was done and when.
Yeah, and you mentioned even leveraging this at the point of work for your inspections, which inspections are detection, and detection often leads to correction. I guess, Leanne, could you talk a little bit about how AssetWatch is also automating this type of data?
Happy to. Yeah, here's our AssetWatch alert page. You can see right here from the screenshot where the integration really starts to come to life between the systems. You'll see that this has an alert open, and there's also a pop-out here that has the chat functions between our condition monitoring engineer and what a customer would see and be able to respond back and forth to. So in this particular example, we have where the condition monitoring engineers cited an observation, and then they cited the next step of what action they need the customer to go ahead and take. When our condition monitoring engineers make that step to put in there that they need to go and check something, it automatically creates and triggers the work order over in MaintainX. And you can see in the screenshot there, we even included a direct hyperlink for our customers directly to that work order. Then once that work order is completed on the MaintainX side, you also see then what happens in the next step. We have a very nice automation between the two systems that will actually close out that next step and alert our condition monitoring engineer that some type of action was taken and that work order was closed. With that, Chris, I'll let you take a look at the MaintainX side and give us a few details on it.
Yeah, absolutely. I think what we're again showing here is the ability, data provides insight, visualization, and I think what MaintainX brings to this partnership is we're the wrench, right? We're the execution tool that allows us to automate a work order, to prioritize it, to attach categories and failure modes, and then to report back into the system indicating that work has been completed.
I think with that, it'd probably be a great time to dive into some lessons and best practices that can be shared with other manufacturers. Chris and Chris, I think this would be an excellent point for the two of you.
Sure, I can start that. So I can speak to what we did, what our best practices were, where some of our learned lessons are. First one would be choose the equipment wisely, especially when you're talking about condition monitoring like AssetWatch. Make sure that you're choosing your critical equipment. I mentioned before, we use ABC rating. All of our A equipment is covered by sensors. Now some B equipment, but almost everything that is A rated in every single plant is covered by sensors. Look for hidden equipment, system critical things like required ventilation. We have a class 1 Div 1 facility. Facility cannot run if the ventilation is down. Therefore, the ventilation is absolutely A rated and must have sensors on it. Look for other things like air compressors. Look for those things that no operator or no maintenance person is going to be checking on all the time or be near all the time. Those are great places to put sensors because that can be your eyes and ears on the machine when you're not around it. And then another lesson that I would give is train the maintenance staff, train the operators, train the management, and then as soon as you think everybody's been trained, train them again. And then offer them additional training later, because we don't all remember everything we hear the first time, but when we hear it multiple times, we get more and more of it.
No, I think expounding on that, Chris, and where INX and the partnership team have done a really good job is to think about the enterprise expansion. You started with a phased project. You built a lot of early adoption and successes before getting into more complicated integrations, and communicated where those were in the journey, and being able to standardize the data management model, right? How you would deploy that across the enterprise, particularly with your global footprint, has been a huge success, because now you are connecting data from at least 13 or 15 sites that are live, and building more complete machine models, not just on machine collected data, but also those TPM red tag requests that are that extra layer of data that are going into your algorithms for predictability.
Thank you to both of you for sharing some of those best practices. Those were great to hear, and I'm sure there's a few people in our chat that found them to be very insightful. With that, let's go a little bit deeper from exploring from reactivity to being more predictive. Chris Rogers, is there some things you want to go into about how INX chose a site?
Sure. So the first thing to choose a test site for us was, one, we needed somebody that was very willing and that needed help. So we chose a site that was having more breakdowns than they wanted, that was seeing some problems, and was very willing to see improvement from that. I like the part about training site level champions. Rather than choosing a champion, we identified that the managers are going to be the initial champion, but then we let the champions for the project emerge after we did our initial training and started to see who was utilizing and learning that platform better. Of course, deploying the predictive tools, embedding the reliability practices, those are an absolute critical step in your phased approach. Because if you don't deploy the tools properly, then people see them, but they aren't going to utilize them. When we talk about adoption, having people in and not just on a screen frequently helps with understanding, so hands-on workshops. And that can help a lot once you've identified those champions, because they can lead on-site workshops for their peers to continue that learning and to continue the training. We have identified a champion actually in one of our sites, which is a really good anecdotal story, I guess you could say, who was a machine operator working on the floor, had been with us for a reasonably short amount of time, who is now doing analysis on this data, took to the platforms very, very well, and has moved out of production into an analyst role. So it's taking that and giving everyone input and showing them that there is room for moving forward and moving up and moving on with what they're learning, helps us shift our culture from I'm going to identify something and maintenance is going to fix it, to we need it to be reliable and it's my job to. It's everyone's job to keep the equipment running.
Chris, I love how you mentioned that it's a culture shift, that reliability is everybody's job. With that, perhaps you can elaborate a little bit on some KPIs that you established on how this was tracked in real time.
Sure. So INX lives and dies on KPIs, I'm sure, just like every other manufacturer out there. When we're talking about establishing KPIs for our equipment, so the KPIs that we chose to look at are availability of the equipment, the planned downtime, and then the mean time between failure and MTTR. So those are both very critical and very hard to measure if you don't have all of the information that you need. So we are tracking these in real time. What you're seeing here is the percentages that we set as our goals or as our targets for each one, or the actual hour numbers when it comes to MTBF and MTTR. I would encourage each company, as you look at something like this, not to just reach out and take it from another company and say, oh, these are the right numbers. This is the right number for us at this time, or at this point in time. This may not be the right numbers for you. So you have to take into account what's happening in your company, what your needs are, and what can you, what kind of time frame can you absorb for mean time between failure and mean time to repair. Both of those can be accelerated with money, but and staff, more people. But what can you absorb, and what is the right number for you? So as we progress, these numbers will change for us. As we get better on that reliability culture, hopefully we will see each of these numbers improve to the point that we may even have to change our maximum scale that we're aiming for.
Thanks for sharing that, Chris. It is great to see where you guys started at, where you're ending up and wanting to go with this vision, how you've intertwined your systems to have a better reliability program. So I need to ask, what's next in your journey here?
Sure. So let me look backwards just a little bit and then walk forward into the whole journey. So bringing MaintainX into our plants brought visibility and structure into our preventative maintenance and our professional maintenance programs. We have created standard work order templates. We mentioned the QR codes, which help everyone get access to the information on that asset very quickly. Incorporating AssetWatch puts the right data in the right hands with the help of their dedicated condition monitoring engineer. So I don't need to have a condition monitoring engineer on my staff at each facility, because that is part of the package with AssetWatch. We are now able to monitor MTBF. We're able to track. We have performance dashboards, not just for our operations, but now for our maintenance staff as well. So now we're able to start benchmarking the reliability of equipment across multiple sites. We're able to see how the same piece of equipment running in one site is running at another site. We have focused heavily on frontline adoption. So that means we have to make things simple. They need to be mobile, that the operators can actually utilize this in the course of the day. And what we're talking about here with MaintainX and AssetWatch being integrated into each other definitely fits that. I want to bring in, and this is not a sales pitch for them, but we have a third partner called Odin. Odin is basically a high-level MES system. It does a lot more than that, but for the purposes today, it is a high-level MES that monitors uptime and downtime on all of our machines. So the basic idea here is to have Odin push real-time utilization numbers into MaintainX. So now we have not only condition monitoring, but real-time utilization in MaintainX. So we can begin switching from calendar-based maintenance for preventative maintenance to actually doing it based on the usage of the machine. How many hours was the machine used rather than what's the date? It's no different than changing the oil in your car at 5,000 miles instead of changing it at 6 months. So my goal for the future is we're going to finish deploying this integration to all of our US sites early in 2026. We are already kicking off some of the integrations in one of our European sites. Actually, earlier this morning was our kickoff meeting, and we'll be moving into South American sites shortly after that. So we have a meeting next week with representatives from our parent company from Japan, and we will be showing them in Charlotte in real time what the integration looks like.
Wow, Chris, to piggyback on your oil analogy, it seems like having real-time accurate and easily to visualize data at the point of work is your new synthetic lubricant.
Good analogy.
And with that, after you've shared those wonderful insights, and I love seeing the journey and where you're heading and getting to be a part of it, let's change it over to taking some questions now. I know that chat has been really on fire with back and forth. So I know one question at least pending, and I think Chris Hudson, you're going to take that.
Right, me and our CPA. Is this the tax question? Yeah. Tax strategies for carrying enough spares to reduce dependency on suppliers. So yeah, that's, supply chain management. Certainly one of the things that will aid in that ability to build accurate MRO, maintain, repair, operation, component parts forecast is the ability, again, to scan QR codes and ensure the discipline of all spare parts being added to a work order so that not only labor but material costs, that total cost of ownership is captured. So I think it's accurate MRO parts forecasting, the ability, as Chris said earlier, to interplant transfer global spares, right? So it's kind of that hub and spoke management principle where you don't want to carry the same parts at every location, particularly when some of their locations are less than a day apart. So using those inventory transfers, and then I think it is going to vendors to find out on long leads and some of the class A items that are particularly expensive, that there is a vendor managed program, and that could be even consumable inventory management. But I guess in terms of the tax implications, it's reduce the overall carrying cost, right, of the total inventory value. And that's, again, going back to those items that we just talked about. I think also it's increasing your inventory turns, right? So that you reduce that excess and obsolete, which tends to have large tax write-off consequences. So I don't know if that answers all of it. We could get into specific tax laws and depreciation methods, but
All right, let's cover another one here. How did you integrate into your equipment? All equipment is unique. How does this relate to our equipment for detecting these anomalies?
That's actually a two-part answer. We integrated SCADA systems across all of our major sites. And with a SCADA system, we're actually using a software called Ignition. That's not the only SCADA out there. It's just the one that worked best for us. We found a great integrator that was able to find solutions even for our 50 and 60-year-old equipment to be able to capture at least uptime, running time, energy consumption, in some cases temperature of the equipment, hydraulic pressures being run at a very low cost. Of course, newer equipment already has PLCs that integrate directly into the SCADA system. So now we have all of that information at our fingertips. We use SQL as a historian so that we don't have to clear out the historian every so often. We're able to run that as far back as we want. The other piece of that is we've mentioned AssetWatch, and I'm sure they're probably answering this in the chat for people, but AssetWatch provides the sensors for measuring the vibration and temperature. That is actually part of the service. That's how their service package works. And so since most of our equipment did not have vibration sensors on it, and choosing the right vibration sensor, depending on the piece of equipment, is a big task and requires a lot of engineering horsepower. This was the better solution for us to say, you give us the sensor, show us where to put it, and then help monitor it for us and tell us what we need to do about it. So actually, it's funny because the image on the question slide looks like it's one of the vibration sensors that we have from AssetWatch.
yeah, and I think, Chris, in that question, it's, really evaluate your vendors based on their open API. For example, you have a sort of a pre-built solution, but MaintainX also has a native ignition module that's easily connectable and allows users to really filter out the noise of thousands of PLC tags to really identify, like you all did, just the protocols and the parameters that you really want to automatically create work orders for, so that you can complete a work order and then close loop, turn that ignition light back to green. So those are all tools in your overall integrated ecosystem.
For me, the bottom line is, if you don't have the integration capability in-house, find the right integrator out there. There's some really great ones. And then talk to your partners. Talk to MaintainX. Talk to your AssetWatches. Talk to, in our case, to Odin about what they can and cannot do and where they can help you in those pieces to get everything connected.
All right, let's jump to another one here. How are you able to replicate the project from one site to others in such a short time?
Wow, that's a deep one. Well, one of the things was, like I just said, talk to your partners. So Odin, AssetWatch, and MaintainX all assigned us people who are directly responsible for making sure that the implementation happens at each site. So my team within our company is very small, but by leveraging partnerships with these other companies and bringing them into the sites, I'm able to get sites up and running while other sites are still in the process, if that makes sense. We did not do one site, then one site, then one site. So as a site is, I'll use the integration to the SCADA. As one site is being integrated into the SCADA, we are investigating how to integrate the next site. We don't wait until the project is completely done at each site.
And because you really built that standard architecture on how you were going to connect these systems, and then based on each site, based on their assets, their parts, their technicians, you were able to kind of go through the menu and say, okay, these are the discovery requirements for each location. And that was built into your phase rollout. So
Right.
each site, even though it was trained and launched separately with lessons learned, there was that master schedule with timelines built in and the architecture standardized.
Correct. And having that overreaching architecture, and you keep mentioning hub and spoke. Our SCADA system is set up on a hub and spoke, so that I only have one outbound data port for anything going out to the internet. So a lot safer on the data side, being able to collect that. But by leveraging the lessons that we learn with each of our vendors, each of our partners at each site, every site gets a little bit faster and a little bit faster and a little bit faster.
All right, let's see here. This is a good one. Repair parts lead times have been and continue to be a big hurdle for effective maintenance management. Is there a good strategy for handling lead times? I've heard both of you mention a little bit here about the MRO, so let's dig a little deep into this question.
I think it goes back to the same approach that Chris mentioned on asset management. It's to really go through that ABC inventory classification on components, right? To make sure that not only your fixed lead times are accurate, but all of the other data within, say, your ERP system, that the data has been scrubbed and is believable. Then it's to build, the one part for each of those critical A items, to look at the lead times, talk to the vendors, and in some cases, you may have to increase EOQs, your economic order quantities for those critical parts. But I think also in being able to build MSAs, where you have master supplier agreements with your critical vendors to really negotiate down lead times. It's amazing if you do go to them and show an accurate forecast, how they'll be a little more open to carrying some vendor stock.
Absolutely. No names, but we do have a vendor out of Europe who the lead time for certain parts for them is 3 to 6 months, not weeks. So you can imagine, since we have that common equipment across multiple plants, the plants with the largest amount of each one store the critical parts for maybe 2 pieces of equipment to be repaired. And then the plants that don't have it are able to order internally from the plant that does, and then place an order to replace that in inventory. Most of the time, our vendors have been really helpful in working on those lead times and providing us with lead time information. We keep that in our ERP system for the lead time information on those parts. So when the CMMS kicks an order over to the ERP system, we already know what the lead time is.
Right, and because we're accurately consuming those spare parts at the point of work within MaintainX, we're short cycling the days that otherwise might have been delayed while you're trying to accurately account for parts that were consumed. So I think there's other strategies, right? When you talk for a plan for each part, there's many lean strategies. Some of them are even looking at bench repairs. If you have a 50 horsepower motor that fails on average, failure mode says once every 2 years, it's consider a spare, and then the other one gets sent out for repair, right? And so again, I think it really does leverage if you can go to vendors with data across your entire enterprise that INX has, and then to do that hub and spoke inventory stocking, so you're not duplicating parts in every location.
A good tool for engineering or maintenance staffs that are trying to do this is the FMECA, the failure mode. And so you're not just doing your failure modes, but you're also looking at the criticality of the equipment. So now that you know where the failure modes are, you can determine which parts you have to have in inventory based on what Chris was just saying, your agreements with your vendors, your lead times, and everything else.
I love your answers and all the questions that we've gotten. Unfortunately, we only have time for one more question. The last question is, what type of new skills or training were required for different users?
Wow. Okay, that's a good one. New skills. We have a mature workforce at some of our plants, so computer skills were very important. Some of the operators had very limited skills, so we were able to leverage some internal training for that. As far as other new skills, maintenance staff needs to be able to do more as far as mobility. So that was a little bit of training for them to get away from using paper and clipboards to using tablets and handheld devices. Other than that, most of the training that was required for each of these platforms was provided by the partner.
That is great. What a great answer to our last question. With that, I do unfortunately have to close the webinar. Thank you, everyone, and a huge thank you to both Chris Rogers and Chris Hudson for joining me and sharing some insights today. We hope this webinar helps you see what it really takes to move from predictive maintenance data into reliable action and how to get the most out of your program, like Inc says. We'll send a replay and key takeaways shortly. Thanks again for joining us, and we'll see you at the next webinar.
Thanks, everyone.
Thank you.